Hello, everybody, and welcome. My name is Micah Silverman, and we're going to start a stream here for a program we call Stranger Danger. And we're focusing on Java today, but it's pretty applicable to everybody, I would say. And before we get started, I just want to introduce my wing person here, which is Sonia. Welcome.
Hey, hi everyone. I'm Sonia, Senior Security Advocate at Snyk. Yeah, just helping here. I hope everyone is going to have fun during this session.
Awesome. Thank you, Sonia. So Sonia is going to pay attention to the comments, interrupt me whenever necessary. I have no sensitivity around that, Sonia, so feel free to just pop in and interrupt me if there are questions that I haven't seen. And please feel free to drop comments into chat, and it'll come across to both YouTube and Twitch. All right. I'm going to temporarily remove Sonia and let me go. And Sonia's still with us. Don't worry. She's just off screen. I'm going to share my screen. Let me put that in. There we go. All right. I'm assuming everybody can see my screen here. So what we're talking about is what we call stranger danger. Your attack surface just got bigger. My name is Micah Silverman. You can @ me at @afitnerd. And just a quick little background about myself. I'm a Java developer for the last 27 years. That's since it was first released in 1995. This is usually when I say get off my lawn, but don't get off the stream. We're glad you're here. I co-authored this book, Mastering Enterprise Java Beans, just in time for that technology to be kind of irrelevant, but something I'm still proud of. I contribute to a bunch of open source projects. I lead one of our DevSecCon chapters. DevSecCon is a standalone nonprofit organization. It brings developers, security professionals, operations professionals together. We have lots of meetups all across the world. And I'm proud to say I founded our first North America chapter, our first US chapter in Virginia. I like to build these full-size MAME arcade machine cabinets. It's kind of a hobby. And in Dungeons and Dragons, I'm a chaotic neutral. That means that I like to mess around with people and do no real harm, but I do like to troll a lot. And that turns out is really great for a career in DevSecOps. Messing around with system, probing the edges of things. We're going to be looking at a bunch of that stuff as we go here. So let's jump right into it. Now, this is an interactive session, so I want you all to get your browsers ready. And excuse me, in pretty short order, we're gonna jump into an interactive part of it. But first, let's take a look at the problem space that we're dealing with. I probably don't have to tell you that software delivery has sped up quite a lot. If you've been around for a little while, like I have, back in the day when I was consulting for big insurance companies and banks, things were quite slow. We would release once a quarter. That was part of our release cycle. And that seemed fast to the bank. That was like a radical concept, releasing software that fast. But we would work and work and work. And our focus was on features. We had to deliver these features. We might have to interface with a database team. We'd have to get all our features together that we were going to build for the quarter. And then we had a small window to release. And we had to explicitly release over a weekend. And if we missed that window, there was a whole pile of exceptions that we had to get, and nobody wanted to be in that boat. And the tricky thing was that right at the end of the cycle, maybe in the last week of this 90 days worth of work, we turned this over to our security team for an audit. And if something came back, if something got kicked back to us, we really had to scramble to fix that. So the good news is that software delivery is sped up, but the bad news is that still little thought has been given to security. We've done a really good job, I think, in the developer community of paring down and quantifying well the units of work that we're going to work on. We have all kinds of approaches, Kanban and Scrum, and those have really helped, at least in my experience, to deliver better quality work, deliver tighter bits of work product. But still, we're focused on features, certainly a lot more than we're focused on security. And so a lack of security focus throughout the lifecycle still brings us to this point where we may have a siloed security team that's going to give us an audit and maybe kick things back to us, and we're still scrambling around, except now it's at the end of the month instead of at the end of the quarter. And of course, the biggest problem is customer data could be compromised, and we have a lot of examples of that, and we'll see some of them today. So how bad is the situation? Well, if we take a look at the modern application, we can really start to look at it in through the lens of a new risk profile. And along the left here, in case it's not completely clear, that is not a mountain. That is the tip of an iceberg. And the iceberg metaphor works really well because, as you probably know, we only see the tip of the iceberg. That's only maybe 10% of the overall iceberg, and everything else is below the surface. So in the context of software development, 10 to 20% of our code is custom. That's the tip of the iceberg. Everything else are the libraries that we rely on and other systems that we deploy our code to from the perspective of risk, from the perspective of security. So here's an example in Java, and it may be very obvious what the problem is. So I'm asserting there's a problem with this code. If you see it, feel free to drop it in chat. But just imagine as a kind of, high functioning developer, we've got a lot of pressure to deliver features. We're writing code as quick as we can. This is a really obvious one, but we introduce security issues into our code all the time unintentionally. Now, in this particular case, what we're looking at here is a classic cross-site scripting issue. It could also potentially end up being a SQL injection. The main problem is that we have unsanitized input going directly to method call, going to some sort of output. In this case, it's going to write whatever we pass in as the user, it's going to write that directly to the browser page. And that gives us all kinds of opportunity to embed JavaScript and get up to other trouble. So this is in the custom code that we're writing. This is a very simple example, but the point is that we introduce security issues all the time and can remain unaware of it if we're not careful. Now, the very next layer down is open source, and modern applications, somewhere in the neighborhood of 80 to 90% of the code base is open source. And if you're like me, I tend to think of my application as the code that I've written. Maybe a couple thousand lines of code in a small application. Not bad. It's tight. I got tests around it. It's really easy to manage. But really, the surface area of my application has to include all of the libraries that I'm using and maybe frameworks. In the case of Java, I use Spring Boot quite a lot. So, scratching my head wondering how many lines of code do I think there's in Spring Boot? Probably many orders of magnitude more than the custom code that I've written. And the surprising thing, it was surprising to me, is that 80% of vulnerabilities are found in indirect dependencies. That is those transitive dependencies. So maybe I'm using a library that I contribute to in my project. I contribute to the Java JWT project, Java JSON Web Token. So I am very familiar with that library. However, that library has its own dependencies, and I am less familiar with those. And that's where 80% of the vulnerabilities that we find are going to come from. So it doesn't even help if we're intimately familiar with a particular library that we're using, because vulnerabilities are going to come from those transitive dependencies, and we can't possibly be intimately familiar with every single aspect of every library that we're bringing into our application. So this is the nature of the double-edged sword of open source. We as developers have gotten a great boost in productivity because we can bring in these libraries. Like if I want to have my application support Markdown, I don't have to write a Markdown parser from scratch. And thank goodness for that, because I'd probably introduce a whole new set of issues and bugs and things that I'd have to fix along the way. I can take a nice, mature, open source Markdown library and bring it into my project. But this library is going to have dependencies, and those dependencies are going to potentially introduce vulnerabilities. So let's jump right into a live example. So Sonia, if you would drop this URL into chat, https snyk-chat-goof.herokuapp.com. I'll leave that up for just a second, and then I'm going to switch over to my browser and I'll highlight that URL once again. So it's snyk-chat-goof www.herokuapp.com. And let me see if I can zoom in on it here. There we go. And when you get to the front door, just put in a username. It doesn't have to be your real name. And you'll notice this interface that we're looking at here. This is what I'm going to say is a modern chat app. Now, don't ding me for the design of this. I am not a very good front-end designer, but it's a modern app from the perspective that it's a JavaScript front end, a Java back end, and it uses WebSockets to communicate. So that's pretty modern. Now you can add different rooms. What I'd like you to do is come into the main room here with me and then click on Start Chatting. And we have this nice chat interface. Okay, fair enough. So, and we can just start typing here, pretty typical, straightforward chat. Sonia's going to see this. I'm going to see what she types because we're dealing with WebSockets. So pretty good. Nice modern stack app. It's deployed to Heroku. I'm going to have to change it pretty soon. RIP Heroku free tier, but I'll get to that at some point. Now, when I see an interface like this, being a chaotic neutral, maybe you're similar, I immediately want to start messing with it. I want to see if I can inject some JavaScript, because if I can, it might not just affect my view of it. Because I know this is a chat app and it's using WebSockets, it may affect everybody that's connected. So this is the first thing that I'm going to try, which is just a simple tag. Script alert 1 script. And I can see that something good happened from the perspective of security. What's good is that it didn't interpret this, the browser didn't interpret this as a tag. There's some level of sanitization that's causing the application to pass that through as plain text, as visual text. And so I see an exact replica of what I wrote, as opposed to the browser interpreting it as JavaScript, because if it did, I would have seen an alert. All right, well, I don't give up that easily, so let's see what else we can do. Before I try the next thing, one thing I neglected to mention is that this chat supports Markdown. And in case you're not familiar with it, Markdown is a very compact markup language for being able to present rich text on the screen. So rather than writing HTML, we use this very terse markup language, and then we can do things like bold and italicize things, and it gives us some nice features, which is very useful in a chat. And among the nice features it gives us are links. So before I hit enter here, let's just look over the anatomy of a Markdown link. And that is square brackets with a label followed by parens with the URL inside the parens. And one thing I will say just as a warning here is that there is no official support in Markdown for having a link open up a new tab or a new window the way there is with regular HTML. I think that's a shortcoming of Markdown. But if you click on this link, it's going to take you away from the chat app. So instead of clicking directly, you can right click and open link in new tab. And then you can see that it's just a straightforward link, right? It brought us to snyk.io. But this is useful in a chat app as well. It's nice to be able to send links to each other. So there we go. But it does offer me a new vector of attack to see if I can inject some JavaScript here. So the next thing I'm going to try is this. Now, this is a perfectly valid bit of Markdown, but instead of a URL, I'm trying to inject some JavaScript there. Let's see what happens. All right, so now this is interesting to me in that it didn't do the same thing as it did with the script here. It didn't convert the entire string to text and just pass it through. What I ended up with is a closing paren. Now that tickles my chaotic neutral spidey sense, and it tells me that I've made some progress here. I could be wrong, but I think I've made some progress in messing around with the sanitizer that's trying to prevent me from slipping some JavaScript into this chat. So I'm going to try again, and I'm going to use a common trick, and I'll explain what it is in just a second. Let me just, let's see if I can do this from memory. That's a bad idea for me to rely on my memory. But what I'm doing here is I'm using an HTML entity. Now, you may not be familiar with that. An HTML entity starts with ampersand pound, followed by a number, and then a semicolon. And that's a way to represent a special character to ensure that the browser renders it as a character. So when the sanitizer converts my or parses my string, it's HTML entities that allow it to be shown on the screen in this way. So it's using the HTML entity for the less than symbol so that the browser doesn't interpret it as a tag. So what I'm doing here is I'm imagining that there's some kind of JavaScript regular expression that's looking specifically for the string JavaScript colon. And I'm trying to trick it by giving it this ampersand pound 58 semicolon, which is the HTML entity for colon. So if I can slip this past this sanitizer, maybe I can trick the system into interpreting this as JavaScript, because the order of operations in your browser is that it's going to convert that to a colon, and then it's going to interpret the rest of the string potentially as JavaScript if we can slide it past the sanitizer. So let me copy this and let's send that through. All right, this is interesting. Now it's like the sanitizer kind of gave up. It didn't know how to render this string, and so we're not seeing anything. To me, that means I've made maybe some more progress. I could be wrong, but I'm going to keep going because I think I'm making progress here. All right, now here's the last little bit of trickery, and I didn't invent this. This is something that somebody else found out, but I've cheated. I know the answer here. And let's take a look at what I'm doing here. Now, first of all, I want to point out right out of the gate that ampersand pound 58 is no longer a valid JavaScript entity. Oh, sorry, a HTML entity. It's no longer a valid HTML entity. Now, this little hack, I'll give you a spoiler alert, this is going to work, but this combines two issues. It combines a known vulnerability in a markdown library. We're going to look at that in a second. It combines a known vulnerability with the knowledge that your browser is overly permissive. What I mean by that is that all modern browsers will interpret ampersand pound 58 as the HTML entity for a colon, even though it's not valid. So let's look and see what's happening here if we can slide this past the sanitizer. We have JavaScript followed by a colon, followed by the keyword this. This is a keyword in JavaScript. It's often misunderstood. I would say this is a little easier in Java, so there you go, but I'm biased. So then we have this perfectly valid keyword, but it ends up being a no-op. Then we have a semicolon, which is the JavaScript statement separator, perfectly valid syntactically. Then we have alert one, and the final HTML entity there is the closing paren. So if we can slide this past the sanitizer, the browser will happily interpret this as JavaScript. And in fact, it does. So now we can see we got a new link, and if we click on that link, if I click on that link, I get the alert. And here's the thing that's so diabolical about this. If you click on the link, you get the alert too. So I've not only affected my locally running instance of this application, I've affected it for everybody. Now, you may say that, well, big deal, it's just an alert, but a lot of hacking and a lot of attacks are kind of foot in the door. And what I mean by that is once we've got a foot in the door, once I know that I can reliably inject JavaScript, now maybe I'll try to do something more significant, like, I don't know, display all of your cookies or exfiltrate your local storage or do something more significant. So the big punchline here is, as developers, how can we reliably avoid these kind of issues when we're relying on open source libraries? Let's take a look at the code here, and I want to show you that I have attempted to be a responsible developer here. Bear with me a sec. I'm going to make this a little bigger. So I've attempted to be a responsible developer because I'm using this markdown library called marked. And this is JavaScript. We're going to flip over to Java in just a minute. And I've set some options, right? So I'm being a responsible developer. I read the instructions, and the documentation tells me that if I want sanitization turned on, I have to pass in sanitize true. Now, as a security professional, that is a little bit of a red flag. Maybe as an open source contributor, I would say, hey, I'm gonna contribute a PR that says sanitization should be enabled by default, and if you really want to turn it off, then you have to pass in sanitize true. That would be a more responsible way to manage this from a security perspective. That would also be a breaking change, so it would have to be, kind of a major version bump. But putting that aside, I've made sure the sanitizer is on. And then here's the third line of code, and that says for every incoming message, pass it into the marked function. So if there is markdown, it will properly render it on the page. So from the perspective of being a software developer, this is great for productivity. With 3 lines of code, I was able to make my modern chat app support markdown. That's pretty great. But as we just saw, there's a problem with this library. So how can I have confidence in the open source libraries that I'm using? Well, I want to direct your attention. Actually, I'm going to come back here. Let me do this. So this is the first tool that I'm going to display and demonstrate today. It's called Snyk Advisor. And one thing I want to highlight right from the beginning is that this is a free with a capital F service that we offer at Snyk. What I mean by that is you don't have to sign up. You don't have to give us your email address. You can just come to snyk.io/advisor and start using it. And currently we support these library communities, if you will: NPM, PyPy, Go, and Docker. So JavaScript, Python, Go, and Docker. And hopefully we'll be adding more communities as soon as possible. But the benefit here is that I can do a search for, say, Markdown, and then I get a package health score. Now, if you're like me in the past, what I did is if I was investigating a Markdown library to use, I would go to GitHub, I'd do a search for Markdown, and I'd look at the number of stars, I'd look at the last commit, and I'd look at things like the last release to get a sense of, how well supported is this library? How popular is this library? And I think that was a pretty good litmus test in the past. I think now this is a better version of that Snyk Advisor, because we're not just looking at the popularity or the last commit. Here we can see you have a score out of 100. You can see there's a lot of options, right? Well, I'm going to choose the option with the highest score, in this case, 100 out of 100. And we don't just look at maintenance and popularity, which is kind of what I was pointing to when you look at things like GitHub stars and last commit. We also look at the community. How many contributors are there? And of course, I would say the most important dimension is security. Are there any known vulnerabilities in this package, in this library? So security is very important. I would say the most important, but it's not the only thing. We look at popularity, maintenance, and community to come up with this package health score, and this gives you a much higher degree of confidence in a library that you might use. We also provide you with all kinds of other stats that may be relevant to you. For instance, sometimes the most popular version of a library is not the most secure. In previous versions of Marked, this Markdown library, we saw that where the most popular version was one that still had a few vulnerabilities left in it. Now, you might be wondering, well, why does Marked have a score of 100 out of 100 if I just demonstrated that we can do a cross-site scripting attack with it? The answer to that is that I cheated, and I'll show you the way that I cheated was that I am using an extremely old version of the Marked library. Ooh, let me get rid of that. I'm using an extremely old version of the Mark library, 0.3.5, so pre 1.0. And that version is from 2015, I think. And if I go and look at a specific version, I can change this up here to 0.3.5, and we can see that there are all kinds of known vulnerabilities with this version of the library, including things like cross-site scripting attacks. So just by looking at the version, maybe there's some reason that you need to use a version that isn't the very latest version, but you can see the issues with that specific version right away. So super useful tool and having a higher degree of confidence in the libraries that we're using. The other thing, the next tool, so to speak, that I want to highlight and draw your attention to here is the web version of Snyk. So with Snyk, you can scan your projects. Scanning projects with Snyk is super important because one of the benefits that you get is the ability to put up a pull request. Now, like I said, this Snyk chat goof, this is a modern application. It's got a JavaScript front end, a Spring Boot backend, and we can see here that Snyk has analyzed both the Java portion of things from the perspective of open source libraries, that's the POM XML, and the JavaScript side of things, which is the package JSON. So you get a holistic view. It's also analyzed my code and it's found some issues in my custom code. So this is the Snyk interface. You can go set up a Snyk account for free. There's a developer tier. It's free forever. It's fully featured. The only limits are on the number of scans that you can do per month. But what I want to show you here, one of the benefits you get from using this web interface is that when it does find vulnerabilities, you can click on fix these vulnerabilities and it's going to create a fix PR for you because you've given permissions to Snyk to be able to do that. Now we don't auto merge it. We come right up to that point. Oh, this is what we call the demo monster. So something went wrong here. But we come right up to the point of merging it in directly for you without actually doing that. All right. One other quick thing I want to show you in the world of Snyk is we have IDE integrations. And I promise we're going to move on from here and get into some more examples. This isn't all about Snyk, but Snyk can help you with these issues. And right from the IDE, I can do the same sort of scan that we saw in the browser, and it's going to give me the same feedback. So one of the things I like to say about Snyk is that as a developer, it meets you where you are. If you like to be in the browser, you can use Snyk there. If you like to, if you spend a lot of time in an IDE, you can use Snyk there. And we can see that it gives us the same results here that we saw in the browser, where it's telling me there's an issue in my custom code. It's showing me that there are issues in my libraries like Markdown. And then it gives you some of the nice features that you'd expect to see, like the red squiggly lines indicating that there's an issue. And in addition to telling you that there's an issue, we also give you the fix path. So you can see here that if I simply upgrade from 0.3.5 to 0.3.6, this issue goes away. An important point here is that we don't just say, hey, go upgrade to the latest version. We're going to give you this feedback that says, we're going to give you the closest version to the one that you're using that addresses the security issue so that you don't introduce breaking changes. All right, let's press on. Now, we talked about earlier that kind of the biggest problem that we face is that you might compromise customers' data, or your company's data may be compromised, that is. And the Equifax breach, which you may be familiar with, is a good example of really the impact that these sorts of things can have. So 150 million US consumers affected. It was 76 days until it was discovered, and it's cost, as far as we know, $2 billion just so far. Now, The reason that it's worth talking about this is from 2017. We're going to talk about a newer one in just a minute, Log4Shell. Reason that it's worth talking about this is because, like a lot of these breaches, this was a situation where the problem was discovered and fixed very quickly, but still there was this breach because companies lag behind updating and fixing these issues when they're found. So developers often, I know this was kind of my mindset. I've always had kind of a security focus to my practice as a developer. But even so, I had this mindset that the timeline, if you will, for a security vulnerability is that it's discovered, it's disclosed, it's fixed. That's what I thought of as the timeline. Really, the disclosure part is kind of earlier in the timeline than we have a tendency to think of as developers. Because once it's disclosed, that's when developers go to work. And even once it's fixed, that's still the middle of the timeline because attackers know that there's going to be a lag between the fix being released and companies actually implementing the fix. So it's likely that Equifax was not a direct target of attack. It's more likely that attackers were casting a wide net and probing systems to see if they could find somebody that still had this critical issue with Apache struts. Even though the fix had been released, attackers knew that there was going to be some amount of time before everybody updated. And unfortunately, that was the case with Equifax. Now, once it was discovered that Equifax still had this vulnerable version of Apache struts, then it was likely that they became a direct target. So if you're like me, you have a tendency to think of your app as the code that you've written, the custom code that I've written. But we want to expand that view to start thinking of the surface area of our app as including all of the frameworks, all of the libraries that we're using. And we don't want to think of it that way to make this into an overwhelming problem like, oh my, if the attack surface is so big, how am I ever going to address it? We want you to think in those terms so that you can start implementing the processes and using the tools necessary to address the total surface area of your application. Now, let's take a Spring serverless example to kind of drive this point home. This example has 222 lines of code. So this is a function that we can deploy to something like Amazon Lambda and get the benefit of running a function on somebody else's computer, right? You've probably seen that sticker. There's no such thing as the cloud. It's just somebody else's computer. Well, doing things like serverless, that kind of brings it to the next level where we're not even thinking in terms of a computer. We're thinking in terms of individual functions that are going to run somewhere else. So we have this nice little function. It's 222 lines of code, not bad. You may be inclined to think of that as the surface area of attack. I want to make sure my code doesn't have the ability for SQL or the vulnerability of SQL injection or cross-site scripting. I've looked at all of those. I think my code is good, but really we need to bring in a bigger view because this function, this 222 lines of code, has 5 direct dependencies. And then when we look even further, if we look at the whole dependency tree, which you can do with a tool like Maven or Gradle, we can see that there's 54 total dependencies. So with 54 total dependencies and 222 lines of code, what do you think the total number of lines of code are? If you had a guess, feel free to drop it into chat. I don't have a view of chat, so I'm going to keep going on. But either just think to yourself or drop it in chat. How many lines of code do you think we're talking about overall here? And we're going to use Price is Right rules, so closest without going over. Now, the first time I looked at this or thought about it, my guess was 100,000 lines of code. Nice round number. It's kind of extreme. It's like, wow, how did we go from 222 lines of code to fully 3 orders of magnitude more, right? That seems kind of extreme. Well, the punchline here is that it's actually almost 500,000 lines of code. So we really have to take that into account when we're considering the total footprint of our application. Attackers are targeting open source because there's one vulnerability and many victims. And we saw this in great detail with the Log4Shell issue that happened at the end of 2021. Now, I don't even have to ask you to raise your hand or drop it in chat. If you're a Java developer, you were impacted by Log4Shell. And as far as we know, there were no major breaches associated with Log4Shell, and there haven't been, which is great news. The community really rallied around it. But this was even a more serious breach than the one that impacted Equifax ultimately, because it was a remote code execution. It's the first time that Snyk assigned a 10 out of 10 score to this issue because of how serious it was. Now, this is a great example and one that we come back to a lot of a case where having active monitoring makes a material difference. What I mean by that is you had a Java application out in the world on December 9th. Maybe you had a high degree of confidence that there were no vulnerabilities in that application. Maybe you were using a tool like Snyk already and you'd scanned it and you had zero vulnerabilities and everything was happy. Well, December 10th, all of a sudden, there was now a major vulnerability. Your code didn't change. You didn't do a new deploy. It's just that a new vulnerability was discovered. That happens all the time. And if you were using Snyk, you would have gotten a notification saying, hey, in production, you have an issue that you need to address right away. Now, what we found is that there were over 17,000 popular Java libraries that were impacted by Log4Shell. And within the first 3 days of the news breaking, we detected in our analysis 800,000 attacks were attempted just on this vulnerability. And over half of all the projects that are out in the world have Log4j as a transitive dependency. Now, if you're like me, you might have said, well, this is big and scary, but this doesn't really affect me because I use Spring Boot, and I know that Spring Boot uses Logback and SLF4j, so I'm protected. But notice that 57% of projects have Log4j as a transitive dependency, not even a direct dependency. So even though the base Spring Boot uses SLF4j and Logback, in Java, we love our abstractions. So I could be using a library that's using Log4j, and everything in the logging world just works because it all hooks in together. So I can't just rest assured that I'm safe because of the fact that I'm using Spring Boot. I have to look at all of my transitive dependencies. Now, what presentation wouldn't be complete without a poorly drawn diagram? And here is my poorly drawn diagram of how Log4Shell works. So let's go through it, and then we'll do a bit of a deep dive into an example. So how does it work? Well, here's my application, and within my application, I'm using Log4j. Now, prior to the latest version update, if I could sneak a string constructed in this way into the output, which it turns out is not that hard to do. Let's imagine a scenario where you're logging errors for invalid login attempts. And maybe you log the username as part of that, saying username Micah tried to authenticate to the system and was unsuccessful. Well, if you're logging out that username, maybe as an attacker, I can put in this string as the username. And if there's no sanitization on that, it goes right out to the logger. And frankly, we really haven't considered as much what gets sent to the logger the way that we have for things like input on browser pages. Now, once you get a string like this is an interpolated string that's a URL that has the JNDI service, JNDI service called out, and then it has an LDAP URL. What that means is JNDI, the Java naming and directory interface, was built into Log4j. Now, there's a whole separate question of how did JNDI get built into Log4j. We're going to talk about that in just a second. But the Java naming and directory interface is another example of us loving our abstractions in Java because we have all these directories that we want to interact with. We have DNS, what is that, domain naming service. That's a directory. We also have a completely different type of directory called LDAP, the Lightweight Directory Access Protocol. Very different types of directories, but they are both directories, and it would be nice if we had an interface that we could use to interact with both of them. Well, that's what Jindy gives us. So once I have a Jindy URL, Jindy will happily interact with LDAP. And when we think of LDAP, if you're at all familiar with LDAP, you think of it in terms of people and organizations. Sometimes you might think of it as devices like printers. Microsoft Active Directory is a proprietary version of LDAP that builds in a lot of other features and functionality. But what you may not know is that a perfectly valid LDAP response can be a remote Java reference. So if I respond with a remote Java reference to an HTTP server, Jindy will then go and make an HTTP request, and that HTTP request can return a serialized Java class. Jindy will happily deserialize it, and then mayhem ensues. And importantly, evil class is not in the class path of my app. It's not in scope. It's not in the class path, but it does implement an interface. And by virtue of deserialization and interfaces in Java, Jindy will then go execute the method of the interface, and that's when we get into trouble. So this whole issue exists because of Jindy being in the Log4j stack. And the big punchline here is that as the final fix was to yank Jindy out of the Log4j stack. And it's important to understand that how Jindy got into the Log4j stack in the first place was through a normal open source interaction. What we're looking at here on my screen right now is the request to bring Jindy into the Log4j stack. And in the interest of time, I'm gonna speed this up a little, but the punchline here is that this was a normal open source request. The contributor said, "Hey, I have a use case. Here's the patch to add Jindy to Log4j." It was reviewed. It was there was some back and forth conversation, and ultimately it was merged in. And I want to point out this happened in the year 2013. So what we now know is as Log4Shell was sitting there dormant in Log4j for 8 years before it was discovered and disclosed, or before a working proof of concept was disclosed, and that led to the Log4Shell issue, and it led for a fix that removed Jindy from the stack. Now, a couple of attempts were made to make it so that we could keep Jindy in Log4j, but it was ultimately determined that there were still problems when that was attempted, and so ultimately a release was made, and that's the release that is stuck. It's 2.17.1 for Log4j, and it just removed Jindy, and that removed the issue. All right, so we have two main topics that we're going to look at left in the time that we have left. And the first thing I want to do is give you a little taste of the mechanism of how Log4Shell works. And first of all, I have to make sure that I'm clean. I am clean. And I want to demonstrate by setting some strategic breakpoints how Log4Shell actually works in practice. And I want to show you this project. This project is available as open source. We'll have some of those resources at the end. Sonia, maybe you could drop the Snyk Labs Java Goof into chat so we have it there. But this is all open source and available for you to try on your own as well. What I want to draw your attention to here is that this is a multi-module Maven project, and there are two modules that I'm highlighting here. There's Log4Shell Server and Log4Shell Client. And if you notice, this evil class exists in the server but does not exist in the client. That is, evil class is not in scope. It's not in the class path of the client. That's an important point because it highlights why this issue is so serious. All right. Now, the first thing I'm going to do is run the server side of things. And all the server is a very lean LDAP and HTTP implementation. This is not fully functional. It's for the purposes of demonstration, but I have an LDAP server listening on port 9999, and I have an HTTP server listening on port 8000. And that's going to hook into, or that's going to tie into what's going to happen next when we run our main class. So let's take a look at what's happening in the client side main class. And the first thing we're going to do is show some Java stats. That's just about the running JVM. Then we're going to do a normal log output, just a test of our logger. The next thing it's going to do is check for the existence of a temp file. And at this point, that temp file shouldn't exist because as a proof of concept, what we're ultimately going to do is write a temp file to prove that this is a remote code execution issue. But at this stage, that temp file should not yet exist. Now, the next thing we're going to do is make a log output that includes this interpolated Jindy string. And this is going to trigger this whole pile of network interaction that starts with an LDAP request. Then, at the end of this, we're going to check for the temp file again. And then that temp file should exist now because of the Log4Shell exploit. All right, so let's get into it. I've set up some strategic breakpoints, and the very first breakpoint that we come to is within the LDAP stack. And if I look at the server output, I can see that the LDAP request has been made and that it's going to redirect to this HTTP endpoint. And if I look at the output of our main method, I can see that it gives me some information about the JVM. It does this test logger output, and it shows that this temp file does not yet exist. So far, so good. And if I look at where I'm at in the debugger, I can see that bear with me a second here. This is what I want to see. This is the LDAP response. And you may not have been aware of this. I wasn't aware of this, but it's a perfectly valid LDAP response to have a remote Java reference. So by these four attributes, object class, Java codebase, Java factory, and Java class name, I'm referencing a remote Java object. Now, this remote Java object should be a factory ultimately, and the name of this factory is evil. We're going to look more into the evil class in just a moment. But we're going to see that this factory implements an interface, and that's ultimately what's going to allow this remote code execution to happen. All right, so once again, we're deep inside the directory manager. We have these attributes, and if we continue, we're now at the point where it's going to get an object factory from the reference. The reference is this remote Java class. And if we hop over this call and we look at the server console, we can now see that the HTTP request has been made and a byte array has been returned as the result. Now at this point, we have the byte array has been deserialized, and we're going to call the factory's get object instance because we're looking at exercising the method of an interface. Now we can see that the factory itself is this evil class, and by the magic of working within an IDE, I can now see that evil class, even though it's outside of the scope, it's not in the class path of my client. Now, why is the get object instance method going to get called? Well, evil implements object factory, and the only awareness that the directory manager here has is that it's working with an object type, and that object factory type should have a get object instance method by virtue of the fact that it's implementing this interface. Now, if we look at what's supposed to happen is that it's supposed to return an object. But we can see that in fact, what we're actually returning is null because all we really care about is compromising the system. And if I continue into this request, now I'm inside the evil class. And what it's going to do is it's going to execute a command that's going to echo. It's going to write to this pwned file, which proves that we've done a remote code execution. And how are we doing that? Well, we're simply using the built-in Java capability to get a hold of the runtime and execute an outside command, which in this case is going to be a shell command that writes to a file. So I'm going to let that finish, and I can now see that I've been pwned. So this is the mechanism. This is actually how Log4Shell is working in practice. Now, because I'm going to be doing this again soon, I'm going to go ahead and delete that file. But that's kind of your deep dive into Log4Shell here. All right, in the last remaining 10 minutes, let's get into some further down layers of our iceberg. We're not done yet. Imagine that you've secured your code, you've secured your open source, you're using Snyk to scan your project, but now you're going to deploy your Java project to a container like Docker. Well, we now have an even expanded surface area of attack because even though my code and my libraries, I have a high degree of confidence of being safe, maybe I'm now deploying to a container where the base image has some known vulnerability. And like we said earlier, this increase in our ability to deploy quickly has also expanded our surface area. Now, no shade on Docker. We're big fans of Docker. We have Docker captains on our team. Docker Hub is super useful, but kind of like the internet in general, the internet is forever. And so we can go right ahead and use older versions of images on Docker Hub that have known vulnerabilities. So you can see in some of these base images that we pulled, there are lots of known vulnerabilities. And these are the images that you can just reference on Docker Hub today. We asked a bunch of developers, well, when do you scan your Docker images for vulnerabilities? Now, as a developer, I would be in this 50% bucket, or I used to be, that says we don't. I'm a busy developer. I'm not a Docker expert. I know that I have to use Docker, or I do use Docker as part of my daily practice, but I know just enough to be dangerous. So I don't really scan these images for vulnerabilities. In fact, prior to my joining Snyk, I didn't even know you could scan images for vulnerabilities, but spoiler alert, you can, and we make it super easy. We also asked, how do you find out about new vulnerabilities in your deployed container? So this is kind of like the Log4Shell problem, but brought over to the container. Maybe you have something that was running without vulnerabilities, but how are you going to find out if new vulnerabilities are discovered? Well, almost half of our developers surveyed said that they probably wouldn't. So let's take a look at this last hack of the day here for containers. And what I have over here is a little example app. It's a to-do list app, very simple. It's running in a Tomcat container, but I'm not even going to focus on this app. Let's assume that all the code for the app and all of the open source libraries that are used in the app are completely safe, no vulnerabilities detected. Instead, what I want to focus on is the app itself, or rather the environment that it's running in. And I'm running this application in Docker. I've deployed it to a Tomcat container. And I can take a look here at my Dockerfile. And it's relatively straightforward. I'm copying over a bunch of stuff. So I have this image that I'm using. I'm copying over a bunch of stuff, and then I'm using this Tomcat image to deploy it to. Fairly straightforward. I know how Tomcat works, but it turns out that this version of Tomcat has a vulnerability. And I'm going to demonstrate how I go about exploiting that vulnerability in just a moment. So the problem with this version of Tomcat is that it's got a remote code execution vulnerability. First, I'm going to exploit it, then I'm going to show you how we could address that. And I've set up a couple of aliases here to go ahead and exploit that. So the first is a basic exploit to kind of prove that it's possible to exploit it. And if I go and connect to this running Tomcat instance, I can see this is kind of the nothing up my sleeve portion of the show. And I can see that here are the files that are already there. Now, I'm going to go ahead and run this check, and it's going to tell me that that this version of Tomcat is vulnerable. And in fact, it's installed a JSP inside this running version of Tomcat. And in fact, if I look again here, I can see that I have this POC.JSP. So that's kind of the big punchline, is that because of this remote code execution, I've been able to drop off a file in this running instance of Tomcat. This has nothing at all to do with my application. This is all about the vulnerable instance of Tomcat running in this container. Now, I'm not going to go through the whole demonstration. Suffice it to say that with this vulnerability, I could do get shell access, and from my browser, I could start messing around in the shell. In the interest of time, I'm not going to show that, but what I will show you is that Snyk container will run a test against a, oh, hold on. I'm tempting the demo monster. Snyk container will run a test, a scan against an active image. Now, this is a little subtle and took me a little while to wrap my head around. We're using the Dockerfile as a reference to help it run quicker, but this is actually running a scan of the running image on my machine. So it's looking at the version of Linux. It's looking at all of the installed utilities to give me feedback about vulnerabilities that it's found. And if you notice, with this running version of Tomcat, it found 735 vulnerabilities, 71 of which are critical. This is a really bad image to be running in Tomcat because of all these known vulnerabilities. Now, interestingly, if I can upgrade to Tomcat 10 on this JDK, if that would work for my application, and in most cases, at least in my experience, it will work because it's just the container, I bring those vulnerabilities down to 0. That is really great. That is the kind of things as developers, we want to have that feedback, because the only impact to me is to upgrade my version of Tomcat. I don't have to touch my code. I don't have to touch my deployment scripts. I just have to bump this version, and I go from 735 vulnerabilities down to 0. Now, that's pretty powerful. All right, in the last 2 minutes, we're going to talk about the last layer of our iceberg, which is infrastructure as code. The number one cloud vulnerability has been identified as misconfiguration by the US's NSA group. And, this kind of amps up even what we're seeing with containers. So now it's not just that we can have one vulnerable container, one vulnerable machine instance. With infrastructure as code, things like Kubernetes or Terraform, now we can have a whole swarm of vulnerable machines temporarily, potentially. So Snyk scans your code, your open source, your containers, and your IAC configurations. And in many cases, it's kind of like what we saw here. You just need to change some configuration or update your version of something. So the big punchline here is that it's not just about tooling. That's very important, and we do hope that you'll use Snyk, but equally as important is to have a culture and to have processes in place that enable you to build security into your development practice. So this is how, as a developer, you can build security into your practice without you yourself having to become a security expert. At every stage of the software development lifecycle, you can bring in active test, fix, and monitoring tools like Snyk to effectively build security into your process without you having to become a security expert. So shifting left is not enough. You might have heard of the shift left um, topic that we talk about a lot. It's the idea of bringing security concerns earlier into the life cycle, but it's not enough. Really, we want this virtuous feedback loop where all throughout the cycle we're bringing security to the foreground in a way that doesn't slow us down as developers. All right, we're right at the top of the hour. Thank you so much for tuning in. I really appreciate it. And all of the things that I demonstrated today are available as open source projects in our Snyk Labs organization. So that's github.com/Snyk-labs. And you can get everything there. And I just want to thank you so much for your time and attention. And I will release you back to your day. Thank you very much, y'all.